So yeah, hello everyone. I am here to talk about Harbor Maintainer Talk. So welcome to the first talk of the day. And this is my first ever KubeCon talk. And this is the first ever Harbor giving a maintainer talk on Harbor in KubeCon, India. So the topic is about role of Harbor as a container registry in the AI ecosystem and how you can use Harbor in the IoT and Edge workloads. So quickly, who am I? I am Prasanth. I'm one of the core contributors of Harbor, and I work at 8gears, one of the companies that provides Harbor. So I work at full-time contributing to Harbor. To know more about me, you can scan the QR code. And so yeah, disclaimer, I'm not an AI expert or an AI engineer. I'm just a guy who writes code and maintains Harbor. So hope this makes sense. So how many of you already know about Harbor and use it? Can I see your hands? Okay, around 30% of them. But those are people who are new and doesn't know about Harbor. Here's a quick intro. Harbor is a CNCF graduated project and it's an open source container registry that you can self-host, which allows you to store and manage OCI artifacts, container images, Helm charts, and other things. And also, you can have policies, vulnerability scanning, robot accounts, and much more good things. Yeah. So we are a community-first project. So you can talk to us on Slack. We are in CNCF Slack, and we also have a mailing list if you want to talk there. And we also have a Twitter account where we send updates. And then we also have a bi-weekly community meetings on Wednesdays. If you want to talk to us one-on-one, you can join there. And then, yeah, you can scan the QR code to join the Harbor community. So the agenda of this is how Harbor as a container registry gonna take part in this AI ecosystem. So everyone knows that the AI ecosystem is pretty much fragmented. So that is, you have the data sets on S3 buckets, you have your configs on some Git server, and then you have your other models on Azure S3 buckets or anywhere. Like, it's pretty much fragmented, and there is no single way of storing, versioning, and tagging AI models and versioning stuff. So, and we are here to there is no talk about how we are going to distribute the AI models into the Kubernetes cluster. So Harbor as a container registry is already excelling on the distribution stuff, like delivering your containers to your Kubernetes cluster. So now we also have support for AI models. As of latest version 2013, you can now store AI models in Harbor and with the help of Model Pack. So how many of you have heard about Model Pack, GitOps? Any guys? No. So which is Model Pack is a CNCF onboarding project. So it's a sandbox and it has a model spec. So which means it's a cloud native artificial intelligent model format specification, which just means this spec is great because it doesn't create a new spec out of thin air, but uses the OCI spec and builds on top of it. So thanks to model spec, we support it as a first-class citizen in Harbor. So you can package the model spec and then upload it in Harbor. Let's see, this is model file, the model pack. It is pretty much similar to the Docker file. So how Docker is for containers, like you can build, push, and pull containers and store them in registries, you can do the same for your AI models with model file. So it has pretty much the same scenarios, like having a name, what is the architecture of the AI model and precision, family, etc., etc. But also configs. So let's quickly see a demo on Harbor AI models. Okay. Yeah, so this is the modctl, which is a CLI tool that is developed by the Model Pack project. You can use this to package your AI models. So you can, it creates an OCI artifact out of your AI model, and then you can store this AI model artifact in Harbor or pretty much OCI compliant container registries. So modctl build, it has similar commands, as I said, docker build, docker pull, and docker push, same thing, modctl build, pull, push, etc. So now we have built an artifact, and we are going to push this artifact to the demo Harbor instance. So this can take some time based on your AI model storage, how big your AI model is. So yeah, so we have pushed it to the demo instance. So let's now go to the Harbor UI. So you can see like this is how Harbor looks if you are new to it. And yeah, we pushed it to the project AI models, and this is how the AI model looks. And you can also see a tiny logo which states CNAI, which is Cloud Native AI. And if I open the model, you're going to see labels around what the AI model is about and what is the family of the model is, and also the tags. So you can manage your AI models same as you manage your containers and then Helm charts, images, etc. You can tag it, you can version it, you can make it immutable, and pretty much. You can also see the overview of the model, and the pretty good thing is you also get a summary of the model, like a README file. And then you can visualize it, all of these things, from Harbor itself. So that's one of the good things, and you can visualize the license part, and then what is the model contains, such as what is the model artifact contains internally, the file system of the model artifact. So yeah, that's pretty much for the AI model. So now let's move on to the interesting topic, which is Harbor on IoT and Edge. So this is Harbor Satellite, a sub-project of Harbor, which I am one of the contributors and maintaining it. So we have pretty deep questions, like from people who use Harbor, like they want a solution that they can use it Harbor on edge locations. So that is edge locations, they have intermittent connections. They don't have enough bandwidth, enough memory, like enough of anything. So you are running low on memory already, so you can't have a fully mained container registry out there. So we made Harbor Satellite, which allows you to deploy a container registry on edge devices along with your edge workloads. So for example, a boat or a flight or anything where your container workloads run, you can deploy this Harbor Satellite there, which is a single binary, and it comes with a registry, and it's very tiny to run. You can see a GIF that is running here and showing Android. So this is Harbor Satellite running inside an Android, which means it doesn't require that much of a CPU bandwidth or anything. It just has like a minimal container registry that you can run on your edge devices. You can scan the QR code to learn more about Harbor Satellite. So this is the pretty much architecture of the Harbor Satellite and how we manage to do this. So there are three components. One of them is satellite, and the center is Harbor, the central Harbor registry, and the third one is ground control. So ground control is where you manage the satellites. So assigning satellites to different images and groups, and then sending out which satellites should have which images. So it's kind of a rule set. So you can manage it from the ground control, and ground control talks to the Harbor and vice versa. So ground control can create state artifacts and config artifacts. So, and satellites follow this state and config artifacts for its state. So satellite state is pretty much what are the list of images I should have on the edge device. So that is the satellite state, and config is pretty much how much time I should pull, or how many times I should pull, and then what is the interval between each poles, and etc. So these are the things, and this is more like an extension to the Harbor. So if you use Harbor, then you can just drop the ground control that is communicate with the Harbor, and then deploy the satellite along with your edge workloads. And satellites will communicate to the harbor. This follows much more like a GitOps principle, where satellites assume the state artifacts as its desired state. So the desired state of the satellite is the state artifact, and the desired config is the config artifact. So it reconciles itself based on this. And there is a cool guy, Bob, who sits on the top of all this. So he don't want to SSH into all these satellites that is running around all of the globe, like hundreds of different satellite locations and hundreds of devices. If you think of it, you can't SSH or you can't have a script and then SSHing into multiple satellites and doing the config updates, but it is pretty much cumbersome to do, and it is also like, how can you be sure that the satellite will have connection until your connection between your system and the satellite? So that's why this is completely async. So you just set the state artifacts on the satellite, and then you just define whatever you need, and satellite will eventually come to the desired state. So that's all the overall idea. And let's see a quick demo of Harbor satellite and how it's running inside this edge location and all things. So this is Harbor satellite running in an Android. So I started it. So let's see. So this is the catalog command. Like if you know how registries work, this is an API that comes in a registry. Every registry has an V2 API where you can catalog and get a list of repositories and images that is present in the API, like the registry. So now you can see we have a replication feature in Harbor where you can replicate stuff to one registry to another. Since satellite itself is a registry, you can see satellite had previously 2 artifacts, Nginx and test image. Now we are telling satellite to have 3 artifacts instead of 2. So once this replication runs, you can see that satellites reconciles itself to have the extra image, which is registry. Now when we run the catalog command again, we can see there is 3 images that is present in the satellite. So this is like zero touch on the satellite. So you just deploy the satellite and you forget it. So, and it's gonna work. So yeah, that is one thing. And you can also, this also works. For example, if you have a vulnerable image or an image that is has a problem and you want to remove the image from all of your edge workloads, like again, SSHing into hundreds of satellites or hundreds of edge devices, it's not possible. And so once I delete the image from the central Harbor registry, it's going to delete from all the hundreds of satellites. Here we have one satellite that's running here. You can see an image deleted successfully in the satellite. Once I delete from the upstream, it's going to be deleted from all the satellites. You can set this. There are multiple rules and configs you can do. You can, yeah, and pretty much do different types of configs and things. So you can see there is no tags in the test image, like you can request it, and there is no image. It's an empty thing. We can also check if other images are here by checking the Nginx one. Let's see, it has a tags latest, which means the Nginx image is there, but the test image we deleted from the upstream is deleted. So yeah, that is that. Okay, just good. Let's get back into that. Let's talk about some of the interesting decisions that we made. You may wonder, like, what is the state artifact? What is this config artifact? And what is the zero-touch registration, zero-touch provisioning, and what all of it is? Like, the term itself says Harbor satellite, which means once you deploy a satellite, you can't really go and fix the satellite in the space. So that's the same analogy here. You deploy a satellite, and you never need to go to the edge device and do a config change. It's all controlled by the state and config artifacts. And why do we choose that? Because we can, and because it's better to have follow this eventually consistent approach rather than like directly communicating with the edge, which is a push-based method, which is quite impossible and have a lot of failures. If you want to know more about the design decision and things about scan the QR, get the details. And there is even more. Harbor now has an MCP server. So if you guys use AI agents and want to have your AI agents manage your harbor registry on behalf of you. You can use this, and you can scan the QR code to get the project. And then, yeah, let's quickly see a demo of the MCP server now. Okay. Yeah. So this is Harbor MCP server. Like, I connected it to the demo instance. So you can talk like a layman language to the AI, and the AI gonna manage Harbor registry using the MCP server. So this is one extra feature that we are. This is more like a community project. So we are doing it as an experimental thing. So yeah, which project is using more, like if you want to know which tenant is consuming more of your storage or which team is getting more, you can do this. Without this, you may require to do multiple curl commands, but this is more like an abstraction to it, and then you can find out with simple things. Yeah. So yeah, that's yeah. And if you have questions, or if you want to ask something, or if you want to give your feedback, you can reach out to us on Slack, mailing list. We also have bi-weekly community meetings on Wednesdays. If you want there, you can come and hang around. And you can scan this giant QR code to join the Harbor community. And we also have, you can ask questions in the maintenance track after this session. And we also have a project booth, which will be at tomorrow afternoon. So reach out to us, collect some swags. So yeah. Thank you. Thank you all. Thank you all for your time. So any questions you want to ask? Mm-hmm. Yeah. Can we get the mic to the gentleman? Yeah.
Am I audible? Yes,
Yeah.
sir. So I just wanted to check, as you said, right?
Yeah.
If you want to delete any of the artifacts directly, then you can just go ahead and delete from Harbor, and all the satellite edge nodes it will delete.
Mm-hmm.
And that is in async mode. So I wanted to check that how you make sure that, because as you are saying, right, it's distributed globally. So how you make sure that any of the artifacts you have deleted, it is cleaned up from all the edge nodes?
So it is more like eventually reconciled, which means we are not communicating to the satellite. So it's more like a pull-based workflow. Satellite pulls registry every like a set interval, for example, like 1 minute or 2 minutes. Like every 2 minutes, it's gonna reconcile its state artifact. And if it's find any changes, for example, I have set in the demo like 10 seconds. So every 10 seconds it pulls, and it's quick, fast. But you can set it to 5 minutes, 10 minutes, whatever. So it fetches the state artifact from the registry and checks its state with the state artifact. And if the state has changed in the upstream, it will reconcile it, like it goes through all the images that it has. Inside we are using Zot registry. So it is an embedded registry inside the satellite. You can use that, or you can also use your own registry. But yeah, so it reconciles it and deletes the artifact. So it's much more, what do you say, designed to do that way. Pull the state, check if you have the same thing. If not, delete the extra ones, add the new ones. So yeah.
Thank you.
Hi, thank you for the demo. My query is regarding this Harbor satellite on Android. So do we having any production use case where it is already running in the production somewhere?
So this satellite is currently a work in progress. So we have currently become more mature. Then we have started like a year back. We are trying to work on this. And then currently there are no production use cases. There are use cases, but there is no one currently using it in production. But if you want, you can try it out, reach out to us. We can help you. Yeah.
Thank you.
Yeah. Hi, my question builds on top of the first question. So let's say you have an image, you know it's infected with some CV, you clean it up, all the satellites also get cleaned up, reconciled. But then a patch has to be pushed as well, right, to the registries. How do you make sure that that patch is rolled out to all satellites, not just rolled out, but they also run the patched version instead of the infected one?
So patching. So patching would be like you, for example, if uh, you have set a rules in ground control. From ground control, Bob sets some rules, like these are the images that needs to be in the satellite. And you just change the rule, like instead of V2.1 version to V2.1 patched version, and then update it. Once you update it, it's gonna reconcile all the state artifacts of the satellite, and then satellite will also reconcile itself eventually. No. You do it all from the ground control and harbor. No, because the state artifact is just a list of what are the images that it needs to have. If the upstream list says you need to have V2.1 patched, it's going to have 2.1 patched, and it will delete the 2.1 like a normal infected image. Yeah, that's how satellite is designed. Like it's designed to get the state artifact, get the state, reconcile itself to the state. Like it's the desired state if you follow the UTOPS approach. Like the desired state is the state artifact. Yeah. Yeah.
Hi, Prasanth.
Yeah.
So
Hello.
I had a question on why do we need model specification when we already have a lot of these open source model repositories, right, to maintain, or registries, not repositories, my bad. So how does it add value there? Because is it just the artifact management, or is it also bringing the runtime? Because typically when you deploy a model, it's a combination. You pull your artifact version from a particular registry and then put it in a container, OCI, or whatever is the runtime, and then deploy it, right? So how is it adding value?
So if you are using like Olama registries and then Hugging Face, it's like Hugging Face is more like a Git server where you store all the things, and Olama is more like a registry, but it's not a fully compliant, OCI compliant registry. It's a registry that looks like a registry, but there are multiple issues with Olama that normal OCI, if it's a OCI compliant registry, then you should also be able to push other artifacts into it. But Olama doesn't allow that because they have managed to use some protocols and some protocols are missing there. So this model spec, the model pack project, didn't use something that is out of other things. They have built on top of OCI spec. So OCI spec is there, and then on top of that, they have added config options, like adding the family, adding the the data sets and the config and all the family and other things, right? So they are building on top of OCI spec, which means every container registry, like if you package your AI model with model spec, every container registry out there, such as Docker Hub, Artifactory, and what other registries there. So you can push this AI model to any registries. And the good thing is Harbor provides more visualization than other registries, because other registries will treat it as an OCI artifact, but Harbor will treat it as an AI model artifact. So that's the good thing.
Okay.
Yeah.
Okay, thank you.
Hi.
Yeah.
So what kind of resource consumption can we see when it's run on Android device, and can it also be run on a Raspberry Pi?
Yeah, like if you like Android geeks, so Android is a kernel which doesn't have C groups or namespaces into it, which means you can't typically run container workloads on Android. And how have we managed to run satellite is, satellite is just a single binary, and the binary has embedded registry, which means the total MB of satellite would be the package. The binary would be around 5 to 10 MB. And then the runtime is based on your, like how much images are you pulling, and then, but the satellite itself, like idle situation, it would consume around 10 to 15 MB, that's it, like of memory, probably.
Okay. And reconciling, is that also a lightweight operation?
Yeah, it's a very lightweight operation, which is just cool. Yeah.
Thank you. Is Raspberry Pi also supported?
Yeah. So it's just a Go application. So you can run satellite on wherever you can run binaries. And
Got it. Thank you.
Yeah.
So it could be cross-compiled for ARM.
Yep.
Thank you. Thanks a lot.
Yeah.
Hi, I had more questions around this scanning part, vulnerability scanning, and how it is done and how it can be integrated with the existing solutions.
So Harbor has an inbuilt vulnerability scanner, which is Trivi, and you can use this to scan your OCI artifacts, container images, and things. So, yeah.
And how about the signing part, image signing?
Signing part is you from the developer side. So you can sign your artifacts with also Trivi, and there are some signing operations that you can do, like Trivi, notary,
Okay.
etc.
Okay, thanks.
Okay. Okay. One last guy. Okay.
Thank you. Thanks for the session. So one of my question is answered that I wanted to understand it from a point of view that if the edge components are actually bring your own cloud kind of deployments. It can be on-prem, it can be on different clouds. We can run it there. My other question was, how does ground control sync with these? Because when it is BYOC deployments, generally there are a lot of network constraints.
Yeah.
Some outbounds are restricted and things like that. So just wanted to understand that part so that we are sure that the sync happens properly.
So it is more like a pull-based than a push-based.
Yeah.
So which means ground control will never talk to satellite. So satellite is the one that is initiating the connection.
So it will always be outbound. It will always be outbound from the
Yes, from
deployment.
satellite, yes.
Okay, so outbound, okay, we can control it better from a network point of view. The second part was that now we have, say, a full set of registry which has, say, 20 images, and we want to have selective images to be part of the satellite. So you showed it in the demo that when you removed it from the ground control, it got synced to all the satellites.
Yeah.
But we can keep the groups of images as well,
Yes,
right? As
that
part
is what the state artifact is. You can have minor controls like I need this image but only this tag, or I need this image but with only this digest, and you can change it. Like I had pretty much like follow all the latest tag in the project library. I just did that. So that's why it's gonna have like whenever I push to library, every time it's gonna reconcile automatically.
Okay.
So it's like a more developer experience. Like a developer pushes a new thing,
Got it.
and within like 10 minutes or within your set interval, it's gonna become the desired state. Yeah.
Okay, so in this case, now that the registries are synced or the images are synced in the individual satellites, and these edge components are actually running, say, something like a Kubernetes itself, through ground control, can I trigger the operation of the deployment as well?
Sorry, trigger to?
The deployment part of it as well. Now
No,
that we
deployment you should take care. Like you should put the satellites along with your edge workloads, and
Yeah.
ground control doesn't know where your satellites are or how you deployed a satellite.
that would be the extension to the system, right?
Sorry.
That would be the extension to the system. The deployment part of it, right? Once the images are synced, then we have to extend that system to make sure
Yeah,
that they're okay.
So-
Yeah, thanks.
Okay then. So, okay. Yeah.
So my question is, you mentioned about the satellite. So when it comes to the Kubernetes platform, like you are mentioning the satellite as a image which is hosted in each of the nodes.
Outside each of the nodes. You can also like deploy the satellites along with the nodes, right?
Yes, like a daemon set, more like that.
Yeah, more like a daemon set. It's just a binary, so you can do whatever you want. Like
So
you
like you mentioned about the pull-based method as well. Like how it is different from the Argo CD. Like it is also using the GitHub's principle, using the pull-based. So how that is different from the Harbor?
So Argo CD has a much wider spectrum. Like it is used to deploy all the things, but satellites only role is to fetch the state and config artifacts. So it is designed to do only pull that. And why do we use pull is because this is better when you go to the edge and then like intermittent connections. Without this, it would be much tougher. So yeah, this has nothing to do with Argo CD or other things. Yeah. Yeah. Okay, guys, thanks for listening, and I will be here. See you around. If you have any more questions, you can ask me. And yeah, I will be having a lightning talk also. If you want, you can come to Hall 3 and see you guys. Bye bye.